Let us now try to culminate our discussion on the intersection layouts in this particular lecture. In the previous interaction, we talked about the warrants which are there for providing the interchanges. We also looked at the feasible combinations where the interchanges needs to be provided if different type of roads crosses each other. Then we talked about the geometric features and the ramp terminals, wherein the entrance and the exit ramp terminals were discussed. Now, in this lecture, we are going to talk about the weaving sections, the ramp metering, lane balancing, and then there are certain suggestive layouts which can be there for ramps, wherein it takes care of the different type of movements with respect to the roadside activities or the traffic movements on the main highway. So, let us start with the weaving sections. Now, weaving sections means what? First of all, we have to understand at what type of weaving movement is going to be there. Weaving movement is like you are moving in a certain direction and then you have to make a change. So, you started making a change and then comes into this form. But at the same time, there is another vehicle which is going and it can keep going either straight or it can also deviate to increase the speed and then comes on the say the median lane. And so, this type of things, all of these type of movements which are happening wherein the streams are involved. So, these actions are basically the weaving movement and this section is going to be the weaving section. So, we have to take care of these type of movements when you are talking about the any turnings which happens. If there is no lane discipline being followed by the drivers, then it becomes quite difficult to control, because you may find that the people from the right hand side are taking a left hand turn in ahead of a vehicle which is in the adjacent lane on the left. So, if those type of things are happening, then that is becomes a very hazardous situation, but this is what we need to talk about, because in the case of interchanges also these actions are going to be there and then these needs to be controlled. So, we have to see that how it can be controlled, what are the lengths which needs to be provided is what we are talking there. So, here what you can see is the maximum length over which the merging and diverging movements are defined. This is usually 450 meters. But when we look at this, then it talks in terms of two aspects. One is an influence area, another is a traffic density. So, influence area of a weaving section, that is defined by the traffic density. But when we talk about the traffic density, then it is considering all the lanes which are there across which the vehicles are moving. So, it takes the average of all vehicles across all the lanes of the segment between the entry and exit points of the segment. So, whatever number of lanes are there, whatever total traffic is there, on the basis of that we can get the average value out of it. Now, when we are looking at the influence area, then it is reflected by the density of what lane? The density of right and next to right lane, and by the acceleration and deceleration lanes 450 meter upstream of the diverse lane or downstream of the merge lane. So, this is the amount of area which we are going to consider, basically the length which we are going to consider. So, we are going in this form and similarly we are coming in this. So, whatever the acceleration and deceleration lanes, so from here we are going 450 meters and say from here we are going 450 meters. So, this is the total one is particular stretch which is going to be considered for this type of analysis. Now, here what you can see is that there is a merging movement. So, the traffic is coming from here and there is a traffic which is moving on a through lane. So, they are merging at this point. Similarly, there is a divergence. So, here the traffic is getting diverted on a ramp and there is a traffic which keeps going straight. So, there are possibilities. So, here another thing which is happening is that the traffic is merging from here and it then keeps going in this direction, or it may get into the through lane like this. But there is another traffic which is coming from this direction and wants to go straight and gets to the ramp which is there. So, it is exiting now. So, when this is happening, then this is a big area in which the weaving actions or movements are going to be there of different vehicles. So, that is another issue which will be there in this case. So, when we talk about this weaving section, then the lengths needs to be looked at, and these lengths have been defined here. They are in kilometers. So, it is like 0.5 kilometers say to something like as high as roughly 3 kilometers. and they have been defined for different speed values, and they are also being correlated with the entry flows which are in PCU per hour per lane. So, you have the values of these entry flows, they have been categorized, and then they are also being talked in terms of the lane configurations. So, the lane configurations have been defined here. So, when we are talking about these lane configurations, so it is related with like what type of weaving sections or what type of merging or diverging sections with respect to the through sections are there. So, when we see here, what we found is that when you are talking about say the 336 case here, in this particular case the lower values of the traffic, it is coming even less than 0.5 kilometers, but when you talk about the higher flows, then it is roughly around 1.7 kilometers. But when we have higher flows in this type of a segmented condition, that is 333, then the values are going to increase to a lot if we are talking about 70 kilometers per hour as a speed. Now, another thing which needs to be considered is a ramp metering. Now, ramp metering is that you are on a highway and say there is a crossroad. So, a crossroad is being provided and these two roads are crossing each other at different levels, and say we are talking about this type of a connectivity where the traffic goes out. So, you are at an elevated system here and now you are merging at grade. So, when this traffic gets here, there is a two opportunities, one is it goes left, another one is it can take a turn to right and then moves on this one. So, this is one way of doing it. So, another way of understanding it is that you are coming in this form and that. So, the traffic is coming from a ramp and that goes on the acceleration lane and then goes into the main stream. So, the traffic is already there which is quite high on this direction. So, you need to control this particular traffic. So, all of these cases when you are trying to consider, they can be done by way of the use of traffic signals which are placed at these particular locations, and that is what is being defined as a ramp meters. So, when these have been defined and when these have been placed in this way, then what it helps is it helps in controlling the traffic which is moving on the segments ahead, and the traffic always remains with a value less than the capacity of that particular segment. So, that is how the smooth flows or the continuous flows can be maintained. So, this is what is being talked in the other two lines, as you can read also there. Now, depending on the number of lanes and the usage of high occupancy vehicles. So, there can be two different categories of vehicles, single occupancy and high occupancy vehicles. So, when we are having these different vehicles and that what number of lanes are there on the ramp, on the basis of that this categorization is there. What it says, the ramp for single occupancy vehicles, if it is a single lane ramp meter, then for a peak hour design volume is less than 720 vehicles per hour. In this case, or the provision of high occupancy vehicle lane is not feasible. So, we are going to provide a ramp only for SOV. So, these two things, one is the design hour volume is to be looked at, another is the feasibility of a HOV is to be looked at. So, based on that it is going to define. Now, another case is that is still here that the peak hour design volume is up to 720 vehicles per hour, but if the HOV is equals to or more than 9% of the total peak hour volume, then an HOV lane has to be added, and that is where we are going to have a dual lane ramp meter which is there for SOV and HOV. Then ramps for two SOV is another case, that is two single occupancy vehicles. So, dual lane ramp meter is provided. In this case, the peak hour traffic is going to be more than 720 vehicles per hour. So, higher traffic values are there, then even for a single occupancy vehicles more lanes are going to be provided. Now, when we are providing these number of lanes on main highway and we are also providing the lanes on the ramps, then there is some amount of balancing is being done, and that is what is being defined as lane balancing. Now, this lane balancing is done so as to have a continuous, smooth, efficient movement of the traffic, and that has to be ensured with respect to the merging or diverging sections with respect to the upstream or downstream of those merging and diverging sections. Now, when we are looking at this, then what number of lanes needs to be provided? One thing we have already discussed when we talked about the ramps is that it is going to be dependent on the total amount of traffic which is there, and with respect to that we are also going to look at the handling capacity of a lane, and that will define whether we need to have 2 lanes or 3 lanes or more than that. So, this way you are going to have the basic numbers of lanes which needs to be provided. Now, once this basic or the minimum numbers have been defined or decided, then we are going to look at that what are the other things which are happening on that main highway, or how the traffic is being controlled on the main section or the carriageway for a through traffic which is moving in a certain direction. So, here what we have to look at that these needs to be maintained throughout the length of the highway and shall not be kept changing between the pair of interchanges, otherwise the continuity is going to be lost. Now, what is the guiding principle? How to find out what should be the number of lanes under what conditions is what we are looking for. The two cases, one is entrance, another one is exit. Entrance means you are coming from a ramp and you are getting into the main highway. So, that is what we are talking. So, the number of lanes beyond merging of two traffic streams. So, the traffic is here, it is merging, then this traffic is here, this is there, this can also be like this. So, we are talking about the number of lanes beyond merging. So, this is a merging area. Beyond that, what number of lanes are going to be provided here? That should not be less than the sum of all traffic lanes on the merging roadways minus 1. So, whatever are the total numbers which are going to be there in this, say if we have the ramp which is being provided with 2 lanes and it is a 6 lane divided system. So, there are 3 lanes. So, 3 plus 2 is what we are saying, and minus 1, that means 3 plus 2 5. So, 5 minus 1. So, 4 are going to be there. So, if this is 3, this is 2, then this is 4, or it can be maximum as sum of all traffic lanes on the major roadway. So, it can also be 5 in this case. Similarly, when you look at the exit conditions, what it says is the number of diverging lanes on the main carriageway. So, you have diverted, and on the main carriageway what are the number of diverging lanes are going to be there. So, this is number of lanes on the main carriageway after exit plus number of lanes on the exit ramp. So, the traffic is going this way and then this traffic is taking a turn. So, you have an exit ramp here and this is a through traffic on a highway. So, this is what we are looking. Number of lanes on the main carriageway is this, number of lanes on the exit ramps is this. So, we take the sum of these minus 1 is what the number of diverging lanes on the main carriageway. So, this is what is going to be defined. So, if again this is 2 lanes and this is 2 lanes. So, this is 2 plus 2 minus 1. So, that means here it can be 3 lanes, which is now being converted into 2 plus 2. Another point which it says is that there can be certain exceptions, and these exceptions are like for cloverleaf loop ramp exits, and it follows a loop ramp entrance and the exits between the closely spaced interchanges. In those cases there may be some issues and there the adjustments needs to be made in that. Now, what type of adjustments can be there? It says the auxiliary lane may be dropped in a single lane exit, and the number of lanes on the approach roadway can be number of through lanes beyond the exit plus the lane on the exit. So, beyond exit whatever number of lanes are there plus the one lane on the exit, and that is how the total values are going to be there on the approach road. So, whatever is this approach road is there. So, this is what we are saying, and then there is an exit on this direction. So, accordingly we are considering the travel way on the main carriageway should not be reduced by more than one lane at a time. So, this is also one another guiding principle. So, here you can see that here there is a case of a merging lane balance. So, what we see is that it is main highway has 2 lanes and this merging ramp has 1 lane. So, total lanes are 2 plus 1 3 minus 1, that is 2. So, that is how 3 plus 1 4 minus 1 3 5 minus 1 4, and the same way it is being done. So, in other cases the another point which was said that it can be at the maximum equals to the sum of those lanes. So, it is 2 plus 1. So, that is 3, 3 plus 1, that is 4. So, these are the two criteria which have been there. Now, when we talk about the diverging lanes, so we said that how many lanes should be there on this diverging main carriageway was decided on the basis of the these diverging point, and beyond that diverging point how many number of lanes are there on the through as well as the ramp. Based on that, a sum of this minus 1 was the criteria. So, accordingly the values have been calculated. So, this is how we can see that what values needs to be provided at what location. Now, when we are looking at these interchanges, one another thing which needs to be taken care of is that their efficiency has to be looked at, and this efficiency is in terms of the accessibility to the system, that when how you can reach there, how you can approach in terms of entrances or exits, the mobility being ensured, what type of quality of service is being provided, how reliable the service is, as well as how much safety has been ensured. So, these can be the parameters which can be used to examine and evaluate the effectiveness of any interchange. Now, let us look at some of the suggestive layouts. Now, here what you can see is that the traffic is there. So, there is a carriageway on which the traffic is moving, and this is a median. There is a service road. So, this is a bidirectional traffic on this road. So, this traffic can go this way and then it comes here. When it comes here and it is going to move, this is a parallel section, and then finally it will come on this road. So, there is going to be a merging. So, when this is happening, there is a metering being done here. The traffic can be stopped here to see that if there is a lot of traffic moving on this, then this may not be allowed, and hence once there is an opportunity, then the traffic can be allowed to move on this highway and can merge on that. Or there is another way is that this traffic, because we are talking about a two directional condition here. So, the U-turn is also being allowed in this form, and these paths which are there, they are 5.5 meters wide. Now, this is another case where again you have a service road on this side, at the same time there is a service road on the other side too, and this merging action is going here. So, there is an acceleration lane and then the merging is happening. So, the traffic which is coming from here, that is allowed to get into it, but when it is getting allowed here, it is being controlled. Similarly, the traffic which is coming from this direction can get into this way because it has to merge into the main highway. So, again this is being controlled here, and then they have been released and they get into the main highway. So, this is another type of a design where the service road is being continuously provided along the main highway. Here also there is a service road on this side and the service road on the other side, but this can be the deceleration lane on this way, and when it is coming from say this and it has gone into this direction. So, the traffic is going out of a system, it can go to this service lane, or this traffic which is coming from here can also take a U-turn and go into this form. So, this is another design. Here what you found is that there is a service road here and there is a service road on this side too, and then we are trying to see that how the traffic is getting in and out here. So, here the traffic is going out from the main highway, moving in the parallel section, then it takes a turn because it has to go in this direction, or it can go straight so as to go in the right hand direction. So, both opportunities have been provided at this location, but when it is getting merged in the other traffic, then it is being controlled so as to see that the capacity or the smooth flow ahead or the downstream of this location has been maintained. Here this is a 90-degree sort of a condition where the traffic is moving in these directions. There is a traffic which is coming from this service road, and here it is a two directional traffic. So, the traffic can go in this, can go straight and can take a left turn, but if this has to get out and come into a highway, so this is the way it can be done. So, it will come here and get merged, or there is a traffic which is going out. So, it can go straight like this, or it can move here and then get into the system. So, all of those movements which can be possible, they have been taken care of when we are looking at this type of a design. Here now it is a combination of whatever the previous designs we have seen. So, here what you can see is there is a deceleration, here what you found is a acceleration. So, here this is acceleration, this is deceleration is there, and we have the service roads being provided continuously, and there is a another case where crossroad is crossing this main highway as an underpass. So, it is going from below that. So, this is the another type of facility which can be there. This again, though we have the service road which is continuously moving with the highway, and there is a crossover at this location. So, that has been taken care of. So, the traffic which comes from here, so gets out of this, or the traffic if it is coming, it can be out. So, this is how the traffic can move in and out, or there is a possibility of this traffic getting in and out here also. So, all of those things now if you have to do, then you have to see that how these things can be ensured. Similarly, here there is a main highway which is elevated. So, there is a underpass at this location. So, what you found is this is a paved area and this is a paved area, and beyond that we have the service road or the slip lane on all the sides. So, this is service road or the slip lane being provided. There is a crossroads from where the traffic is coming. So, channelization is being done, and the traffic which is moving here can move in this direction or it can move in any of such directions. So, these are being provided. Along with that, whatever this area is being shown, that is a pedestrian path. If you remember, we have seen these things previously too. Here what we can see is that there is a traffic which is moving on this main highway, then it diverts, it starts deaccelerating. But the issue here is that it is getting a one ramp here and then it goes straight and gets another ramp on this side. So, this close proximity of these two ramps from each other may create some issue at this particular point, where a weaving may happen of a vehicle which desires to be here and is wrongly being placed, and that is where it just deviates to the other side. So, this merging and diverging is going to happen in these areas. Here again what you can see is that there is this ramp also is bringing traffic and the other ramp also is bringing traffic. So, there is going to be a lot of traffic in this area, and this needs to be controlled. Either it should have been controlled by way of the ramp metering at the start, but if it is not being done, then these two traffic, when they get into the system and then they try to get into the main highway system. So, this is going to be too much of congested. So, it would have been better if these two approaches which have been provided here, they have been separated out or segregated out by each other. Here what we found is that there is a nose which is being provided here, there is a median and the gap in the median is being provided, there is a ramp from where the traffic is coming, and this traffic can move in this form, or it can go into this direction and get into the other side of it. So, there is going to be a sort of a weaving action which is happening here. So, this needs to be properly designed. So, we have to increase the this merging diverging section or the weaving length, which can go up to a length of say 450 meters, and the sections which can go on the basis of the speeds to some kilometers too. That is what we have discussed previously, is what needs to be taken care of. Now, in this particular one, what you can see is there is a clover leaf arrangement where there are certain permanent structures which are being observed, and because these permanent structures, they cannot be acquired, they cannot be removed. So, what needs to be done is that the design of these clover leaf has to be adjusted. What you found is that in this case it is a good loop, but here this is a restricted loop. So, here probably there is no issue, but here there is an issue. So, this has got a more straighter rather than in a looped condition. The similar thing is happening at this point also. This is one thing, Another thing is that because of the land constraints, whatever area is available, these two structures, they are coming very close to each other. So, in this particular one, it was observed that they were roughly around 1 or 1.5 or 2 meters away from each other, which was not a right design. That needs to be a bit farther away. Okay. So, there was an issue of the restricted speed, and associated with that there was an issue of the radius of curve and spacing of structures. And when we say spacing of structures, this is with respect to ramps. So, they have been taken care of, and then only with respect to the given topography, with respect to the given structures which were there as the physical features, the design has been done. So, this is another case where you found that the roundabout is being provided, and that roundabout the textured surfaces are being used, and these textured surfaces defines the paths for the non motorized vehicles. Or the other way of doing it is that it is being provided in terms of a grade separated condition, where the traffic is moving at different levels, as well as there are spaces being provided for the pedestrians to cross this area at grade separated conditions, say in terms of a subway or so on. So, this is also an important aspect when you have to take care of such intersections in an urban area which is quite busy. So, with this we come to the close of this module, and now we are going to shift to the next module, which is design of facilities. We will start our interaction from the next lecture onwards. Till then, thank you and bye.